Hello. Depending on which time zone you are in when you watch this recording, I bid you either good morning or good afternoon. Unfortunately, I'm not able to join you in person or live online this year. However, I still hope to share with you some insights around the work and progress we at the Woolworths Group are making with regards to natural refrigerants. You'll have to excuse me if I'm a little bit distracted with a cough or a sneeze occasionally. Our household made it quite far without as much as a sore throat or a cold these past 2 or almost 3 years. But COVID eventually brought that record to ground. And I'm still in the recovery phase, so excuse me in advance if I do get distracted. So it's been quite a remarkable 12 months, not just for Woolworths, but I'd say for probably all the stakeholders, everyone joining the summit this time around. Not only have we had to deal with COVID, there's also a very tricky geopolitical reality playing out, which is wreaking havoc with regards to supply chain issues. So it's not just the reparability of components, but what is available is having longer and longer lead times, and it's making it very challenging for, I guess, all of us to meet our construction programs, at least all of us in the retail space. But notwithstanding these challenges, by the end of the Australian financial year, which is the last day of June, we will have 53 stores operating with transcritical CO2 equipment. Now consider that the average store has a trading area of around 3,200 square meters. We're talking about quite large format supermarkets with in the order of 250 kilowatts or more of connected refrigeration load. And we typically service this. In fact, in almost all instances, we service this connected load with twin transcritical racks. So 53 stores really translates to just on 100 operating large format transcritical CO2 systems. Of these 100, 26 have integration with space heating, which means we no longer rely on these 26 stores on the provision of heating via gas-fired boilers or through synthetic refrigerant heat pumps. Of these 53, 12 have both space heating and space cooling. Now, this is quite an achievement considering our very first transcritical store, refrigeration only, was just launched in 2017, really not that long ago. A number of stores have also launched in the cities of Perth and Adelaide. Now, for those of you who aren't familiar with the geography of Australia, Perth and Adelaide are further west than the more well-known cities along the eastern seaboard. Both have very large hot deserts at their shoulders. Now, Adelaide in 2019 actually hit 47 degrees, which is probably unheard of for most Western cities. And Perth last summer experienced 11 days with temperatures over 40 degrees. These are very hot ambient cities, at least in the summer. Not necessarily would transcritical have been considered feasible there up until very, very recently. Now, as we expand our transcritical CO2 footprint and move into more regional areas of Australia, we're having to deal with challenges that weren't necessarily completely anticipated. An example of this is water quality. Water quality in some of our regional cities is actually quite poor. The rock in the reservoirs has a lot of minerals in it, which leads to high concentration of calcium carbonate. Excuse me. Now, calcium carbonate in water is a problem because as that mineral-rich water evaporates on any hot surface, it'll form scale. Now, with transcritical systems in warm climates, you cannot really get around the use of adiabatic cooling of the gas coolers. Now, as much as we're designed to have all the nebulized water evaporated before it hits the coil will invariably get a little bit wet. That wetted coil will evaporate, and with high calcium carbonate content will lead to scale. But another problem we weren't anticipating was a high chloride content. Now, chloride is not the same as chlorine. Chlorine can be very easily removed through the provision of carbon filters. Chloride, on the other hand, is very tricky to remove. And it's also quite a nasty impurity within the water because it will even corrode stainless steel, let alone a gas cooler coil with copper tubes and aluminium fins. So we had to deal with these issues. We had to acknowledge them first and foremost, and then speak to suppliers, work with technology partners to overcome these, to enable us to operate our systems reliably in the long term in these warmer climatic regional areas. Another challenge, which is probably quite common to all of us, but it's quite acute in regional Australia, is the level of experience and skill of our technicians, so installation and service, particularly in regards to carbon dioxide and transcritical CO2 refrigeration systems. So it becomes imperative that project teams for our regional areas are supported by training. Now, in more recent months, we've seen transcritical CO2 systems approaching completion in not so remote but still regional areas of New South Wales. So Canberra, in the Australian Capital Territory, which is about 300 kilometres from Sydney, as well as Young and Wagga, which are about 370 and 460 kilometres from Sydney. So technicians in these areas, they're not necessarily familiar with electronic controls, let alone transcritical CO2 systems. Probably much more familiar with mechanical controls, much more familiar with synthetic refrigerant systems. So it needs to be understood that there be some apprehension as we lead in towards designing and installing and ultimately servicing these transcritical systems in these remote regional areas. So we support these teams. We aim to provide them with a sense of confidence they can sink their teeth into these projects through training. And when we undertake training, we do so in person. I only just came back from Wagga a few days ago. We go through the fundamentals of why we're even looking at CO2 as a refrigerant. And we do so in a language that probably hits home with our technicians. We don't get too technical, but we will explain that 1 kilogram of R404A refrigerant leaked to the atmosphere actually has a greater global warming impact than the tailpipe emissions of an average Australian car in an entire year. Now, if you consider that a large supermarket between refrigeration and air conditioning can have up to 1,000 kilograms of refrigerant and can leak between 10 to 20%, depending on the age and the level of service it has had, 10 to 20% of its charge per year, you can begin to understand the impact that synthetic refrigerants can have as they leak to atmosphere. Now, that coupled with Woolworth's commitment to align with the Paris Agreement and cap global emissions to 1.5 degrees by 2030 means a reduction of our carbon footprint based on 2015 levels by 63% by 2030. But we're actually doubling down on that. We've publicly committed to hitting net zero by no later than 2050. But the reality is we're aiming to achieve that target much sooner. So we provide the context to our project teams undertaking the training. We will review the conventional refrigeration cycle and compare it to the transcritical cycle. Explain what components are present in a transcritical cycle and why they're there, what their purpose is, what is their function. We'll go through the transcritical design brief, the Woolworths design brief, which is the outcome of numerous iterations as we learn, as we progress through our fleet of transcritical stores. Each store actually has with it some learnings which we then document and embed into our design briefs. We go through an installation guide, which is a document that we pull together, which is complete with photos and guidelines on very practical features of installations. For example, how and where to install the gas cooler leaving temperature sensor probe, which is quite critical in the operation or the optimal operation of a transcritical system. We'll also dial into a number of sites which are already operating, and we do that through our cloud-based enterprise system, which gives us remote connectivity to any store within the country. We'll have a look. We'll drill down to the operation of some subsystems. For example, how the gas cooler fans are operating, what their control temperature set point is as opposed to the actual control value. Are the fans hunting? What does good look like? What does bad look like? And we'll do that with a number of the subsystems within the transcritical plant to give the technicians, again, that confidence, that level of understanding that allow them to embrace the technology rather than fear it. And lastly, we'll make our way typically to the plant room where the new transcritical racks have landed. Not necessarily have they been switched on or engaged. Remember, this is before we complete the installation and commissioning. So the racks will be there, and we'll talk through various components of the rack and actually interrogate the project teams who've undergone the training. Show me where the high pressure expansion valve is. What does it do? Why do we superheat the flash gas off the top of the liquid receiver before it gets recompressed by the parallel compressors? Explain to me how that works. Talk to me about the oil management system. Explain to me why we have a separate oil receiver to a oil separator. So it gives us the sense of comprehension following the day's training, but it also gives the project teams themselves a sense of confidence and gratification, knowing that they've actually come some way throughout the course of the training. At the moment, we are, as we do in typical Woolworths styles, always pushing the envelope, always trying to break boundaries or perceived boundaries. And we're working on a transcritical CO2 solution for what the Australian Bureau of Meteorology defines as climate class 2. Now, there are 10 climate zones in Australia. Climate zone 1 covers our tropics. So climate class 2 is only one step down from our tropics. So you could almost define it as a subtropical climate zone. These are very challenging environments with months of hot, humid weather. And we've worked again with our suppliers, our technology partners, our install teams to try to understand how we could think a little bit outside the box and make a transcritical system not only operate reliably, but importantly, efficiency. So when we're looking at total cost of ownership throughout annualized energy consumption, we're still in a favorable position, notwithstanding the very onerous weather to which the system is exposed. We're also preparing the terrain for the uptake of flammable refrigeration systems, specifically hydrocarbons. What we're seeing is a number of hydrocarbon solutions making their way into the broader market, not just commercial refrigeration. So, of course, we're seeing self-contained fridges. But we're also seeing flammable refrigerant ice machines. We're seeing propane chillers and propane heat pumps. We're even starting to see propane split air conditioning systems. More recently, I read an article about an Italian manufacturer of monoblock heat pump room heaters for domestic applications. And we're also seeing propane sanitary hot water systems. So we're starting to see the onset of flammable refrigerant HVAC&R systems worldwide in a number of applications. But the challenge we face in Australia is that our HVAC&R technicians aren't necessarily trained in the safe handling and safe installation of flammable refrigerant technologies. And one of the reasons for that is because safe handling of flammable refrigerant systems aren't core subjects that HVAC&R technicians are required to undertake when getting their licenses. It's not quite the situation in Europe, but it's certainly a reality that we need to acknowledge and address locally. So what have we been doing to address this? Well, we partnered up with a number of registered training organisations around Australia to ensure that all Woolworths stakeholders, so we're talking about installation teams, service teams, team leaders, and also field supervisors, undertake units of competency in safety awareness, safe installation and safe servicing of flammable refrigerant systems. We're also leveraging an online flammable refrigerant course, which is made available by the Australian Institute of Refrigeration, Air Conditioning and Heating, also known as AERA. They've pulled together a great high-quality course under the, direction or with the support of the Australian government. So far, we've had 190 of our Woolworths team members complete the AERA online flammable refrigerant safety course, and we've had 137 of our stakeholder group undertake the safe handling, safety awareness, installation and service of flammable refrigerant systems with our registered training organisations throughout Australia. So we're about 80% of our way through our total stakeholder competency training program. So I've made real progress in that space. In fact, we've already started a minor rollout of flammable refrigerant self-contained fridges as kind of our first step towards really embracing flammable or hydrocarbon refrigerant technologies. Now, in the course of the almost 7 years, I'd say, since 2015, we've also been investing in developing water loop refrigeration systems. Now, one of the primary drivers for water loop within the Woolworths fleet is to develop a specialist solution for niche applications. As our cities become higher and higher, more densely populated, there's less opportunity for us to develop standalone supermarkets, stores. What we're finding is that opportunities are opening up in multi-story mixed-use buildings where we have the opportunity to put a supermarket in the ground floor, but a ground floor which wasn't originally conceived for a supermarket. So that means there is no plant room, there's no condenser deck, and the best the building can offer is a deck potentially 15 or 20 stories above the supermarket where we can put a chiller or a fluid cooler, for argument's sake. Definitely not suited to a direct expansion system, much less transcritical. So we've been building around one water loop store per year since 2015. And again, with each iteration, we've been improving our design and documenting it through iterations of our water loop design brief. Now, up until now, these water loop systems have been with HFC refrigerants inside the condensing unit, inside the individual refrigerated fixtures. So HFC refrigerant and chilled water to shed the heat of rejection. Now, this was always going to be, from day one, this was clear that it was going to be a stepping stone towards a natural refrigeration solution sometime in the future. Now, as we've been building our water loop stores, we've been looking at our NatRef options. And it really comes down to either propane or CO2. Both of them come with their opportunities, both of them come with their challenges. We are in the midst now of designing a store whereby the condensing units will be natural refrigerant. We're still going to be using a synthetic refrigerant chiller on the high side, but that'll be, again, like, let's say the penultimate stepping stone. The store after that will be with the provision of a propane chiller and a natural refrigerant water loop fixtures in the field. So what we'll be delivering effectively is a completely HFC-free refrigeration solution in a building that we probably once considered simply not feasible for HFC-free technology. So with that, I'll draw my insights and update, presentation to an end. I wish that you all have a great 2022 Atmosphere APAC Summit and every success in your endeavours, and hope to see you again next time round. All the best from Sydney, Australia. Thank you.
Collaboration team Panasonic, McAlpine, and Hussmann. So before I talk about today's situation, let me recall what our situation in 3 years ago. This slide is a quote from Atmosphere held in Melbourne in 2019. And I had a chance to talk about Panasonic Hussmann collaboration for that area. At that time, what I talked at the atmosphere was only about training. Training at Japan, we have invited engineers from Hussmann, Australia, New Zealand to Japanese factory and did the training and showed our factory and asked them to touch our technology. And I actually visited Australia and made a CO2 training and supported tests, running the condensing unit. And also for New Zealand, we did the tests and also our training course. So we thought training is the very, most important things to market our CO2 in new countries, because we thought the product will be operate properly if it is installed properly. Installation is a key. And meanwhile, we provided various kinds of commissioning supporting tools, CO2 charge calculations, pipe selection, pipe diameter selection, and suggestion for length, and evaporator selections, Modbus connections, and we also added a selection of expansion valve. This kind of supporting tools were added every time we get a request from customers or installers, and we made a Excel sheet and made a PowerPoint and provided to our customers. This kind of supporting tools are essential for installing the unit properly. But for last 3 years, we have been, we were in the difficult times of the COVID, so we could not visit site from Japan. So we had no choice to ask Hussmann, Australia and New Zealand to do them by themselves. So what have done in 3 years? In 2020, they sold 7 units. This was the first year for them. And second year, 2021, they installed 30 units. And this year, year to date, they installed 22, and the number is increasing every month. So we expect to sell more than maybe 60 this financial year. And we are proud to say that we have no issues for installations. Initially, we had some small issues. They felt they made vibration issues, noise issues, and high pressure error issues. But that kind of issues all came from not wrong installation. If they correct the installation and the issue was solved. For last 3 years, because we could not visit there, we developed remote monitoring systems. Not developed. We collaborated with the Carrel, and we can provide the data file to install Carrel remote control POS-mini series. Then to connect POS-mini with our condensing unit is quite easy now. So this kind of remote monitoring enabled commissioning support even from Japan. So initially, we monitored and made teams discussions and made advice to Hussmann engineers. But as of today, no advice is necessary. They can do everything by themselves. That is the most biggest achievement, I think, for last 3 years, the collaboration between Hussmann and Panasonic. Another achievement they did is adiabatic solutions. Actually, our CO2 condensing unit is survivable for under very high ambient temperatures. Actually, in like Spain, we survived 53 degrees C ambient temperature last summer. So we are confident that unit can survive, but Hussmann team wanted to make sure that unit work properly and well, even under 50 degrees C ambient temperatures. That's why they developed adiabatic solution by themselves. They made samples, trials, and installation manuals and maintenance manuals by themselves. So you can see the papers here. And Japan side, we developed a new product for 3 years. 3 years ago, we had only 2 horsepower and 10 horsepower. But now we have 4 horsepower, which is between 2 and 10. Then we can address needs from 2 kilowatts up to 16 kilowatts, medium temperature and low temperatures. So, even though we had some very difficult time of 3 years because of the COVID, everybody knows, but I'm proud to say that we made a very good achievement as a synergy of Panasonic and Hussmann, Australia, New Zealand, and also McAlpine. 3 years ago, I promised to the market that Panasonic transcritical CO2 will be distributed by Hussmann in Oceania regions. And now I can tell that we are TCO2 solution provider for Oceania market. Panasonic continuously provides CO2 technologies and know-hows. And McAlpine and Hussmann, they have very strong customer base in this area, and they have a wide range of display cases, which is comparable for 8 megapascal CO2 evaporators. So we will continuously expand our business. We are quite confident about this. This is a photograph of Panasonic in Oizumi with the cherry blossoms. It's very beautiful, and it's a pity to say that there was no visitors for this year and last years. So it looks that COVID is over. COVID era is over almost, hopefully. So we hope to see you in Japan someday, and we welcome you. We come to our factory and show our CO2 production line. So this is for my presentation. If you have any questions, I'm happy to answer.
Thank you very much, Gaku. We would like to invite the listeners to submit your questions. So I will be monitoring the chat for incoming questions. Please do provide yours. First of all, thank you for the update. It's great to see the progress in Australia with tens of these units already in the market. And the growth rate annually is quite impressive, right? So you addressed the training to be the step 1 that you have committed to, and it's now you can see the fruits of that work. Gaku, can you please tell us a little bit more about where are these units being installed? What kind of, we are not talking about big supermarkets, right? What kind of operators are you working with, please?
Most of our installations is actually in New Zealand, and our customer is why not Foursquare and Common Sense. But our customer is increasing, so I cannot tell everything.
Okay.
But these are preferred customers.
And these would be qualified as convenience stores? I'm not familiar with all these brands. Convenience stores.
Convenience stores. It's larger than Japanese convenience stores. It's like a small mini supermarket.
Are you also targeting the, let's say, the special applications similar to your strategy in Europe?
It depends. Sales and marketing strategy will be decided by Hussmann, basically. And our main target is now retail. That's what I can say.
Very good. Then can you also tell us about your plans to extend this lineup farther in Australia? We know that in Japan you have larger units available.
Yeah. Eventually, we will release a larger capacity. But we'd like to start from Europe and have more know-how how to install larger CO2 units, and we can bring the technology and know-how to Oceania market.
Okay, thank you. We just had an interview on r74.com with your colleague Benjamin in Europe last week, and he shared, was it 800 units installed in the Europe, or 6 or 800? I believe it was 800 maybe by now. So
no. It's more than 1,500.
Oh, in Europe. Okay. So maybe it was projects. There was number of projects. So 1,500 units installed in Europe. Then this was it. This you have started with Europe in introducing in Europe a little bit earlier than Oceania. Was it a learning experience for you that you can apply in Australia and New Zealand, or is it completely different market?
Of course, what we learned in Europe was indispensable to market Oceania market. So this, today I talked about the commissioning supporting tools. These tools were developed in accordance with the request from European customers. We talked with the installers and realized the necessity of this kind of tools, and made a draft and communicated with customers and get approved. Then we improved many times, and we can give the set of tools to Oceania market. And actually, my colleague in Europe, they did a very good job. They summarized Excel sheet which I made, and made the online tool that is already also available for Panasonic installers under contract.
That's very good, and we are now also in discussion about first CO2 condensing unit by Panasonic to be installed in Manila, in Philippines, at the project. Will these tools be available for this remote type, commissioning as well for Philippines or Southeast Asia, everywhere in the world?
If we have a Wi-Fi connection, yes, we can do that technically. Technically, it's possible. Yes.
Okay, thank you very much. We have one question from the audience. I believe that's more leading. Panasonic is probably more known, likely more known for the air conditioning of your business. And the question is, what's the main application of the Panasonic units, HVAC or refrigeration? If you can please respond.
Are you asking about our CO2 technology?
This is a question about these units that you have presented, and they are solely for refrigeration, if I'm correct. Right?
Oh, yeah. The unit I'm talking today is only for refrigeration, not for air conditioner.
Yes, so that's the answer to Mr. Desmond Fernando. So we will see if there is there's one more. Okay, the question was responded. Very good. So that's all I wanted to ask. Maybe a final question. In Japan, Panasonic has been let's say that the uptake of natural refrigerants in Japan has been driven by the subsidy from Ministry of Environment. Is there any subsidy available in Australia, or all these projects are basically just based on the return on investment and the right thing to do by the end users?
As far as I know, there is no subsidy.
Okay, excellent. Final question. I promise that's the final from my end. Can you comment on the discussions with the end users? Is it more about the sustainability, about the performance of these units, or is there attractive ROI, return on investment, when it comes to installing the CO2 units? What's driving the market in New Zealand? That's basically the question.
I'm not 100% sure, but as far as I know, what they concern most is that units work properly without issue. They want to keep the product cool enough. So that is the most important thing. And after that, after running 1 year or so, they realize that energy consumption is less than another job in the past. Then they are happy to know that the unit is running with efficiently. We don't have exact data for New Zealand market, but that we have been communicating with customers.
Okay, so you have a good feedback from the customer side after the installation, and the number is growing basically faster than ever. Okay, that's a good testimony, I believe. Gaku, thank you very much for joining us again today. It was a very interesting presentation, and congratulations again on the progress in Oceania. So that was Gaku Shimada with his presentation, Panasonic Hand Husband and their projects in New Zealand and Australia. And I am happy to welcome our next speaker, Jonathan Fryer from ISECO, and he will continue this discussion about the latest projects in Australia with natural refrigerants. Good morning to you, Jonathan. How are you today?
I'm well, Jan. Yourself?
Very good, very good. We had a long day yesterday, but great progress in Japan, so that keeps me going for day 2 still. But yeah, it was good to meet the industry face to face after long 2 years, and we do hope that we'll be able to reconnect with all of you guys down under in ARPS in August and beyond that at the in Sydney for the next ATMO Australia. But thanks again for joining today.
No problem at all.
All right, so whenever you're ready, please go ahead and share your screen and we can start with your presentation.
All right. Does that look like what you're expecting to see? You're getting a full screen view there?
So far, we have just your screen and with beautiful sailing boats that I would love to be at one of these.
Oh, you're not getting the presentation.
Yes, you can just open and share your screen whenever you're ready. So far, we have just you there.
Okay, hang on.
There should be a share screen green button at the bottom of your screen. Take your time. No worries, we have time enough.
No.
If you have difficulties, I can also share the PDF from my end, and you can just tell me to switch slides if you have any issue there. Maybe one of the, okay, we are, okay, perfect. So we got your screen. If you can just go to full screen mode and we are ready to go. And please just unmute yourself. Great.
Okay,
Awesome.
how are we looking?
We are good to go. Great.
All righty. Okay, so good morning, everyone.
Jonathan, sorry, just a moment. If you can please just click on that icon to go full screen. It's still in the, it's that one becoming from the, I think from the beginning. Yes, great. Actually, still not changed. I think it's the icon on the right bottom corner. Right bottom. The fourth one. There's a 4 icons in the bottom right corner, and it will be the next to the right. The one on the right next to it. The 4 icons on the bottom of your screen, the one on the right side. If you can see the comment section. Okay, great. There you go. Thank you very much. And we can start now.
Well, it's fine. Right. Except I can't see my presentation, but anyway. Oh, here we go. All right. So you can see me, right?
Yes, we do.
Okay. All right. So this morning I wanted to give you an update just on the latest projects in Australia with natural refrigerants from a consultant's point of view. So starting with the good news, many of the larger and mid-sized cold storage and food processing companies are recognising the long-term benefits of natural refrigerants. And this particularly works best when the information is presented combined with life cycle costing, or some of you might be familiar with the term the TIWI analysis, which is used to justify the additional plant expenditure over the life cycle cost of both the indirect and direct emissions associated with the particular system choices. We're seeing this also flowing into larger retail end users, particularly those who own and operate multiple sites. They've been able to see the benefits of improved efficiency and lower operating costs associated with use of natural refrigerants. And we're also finding that with the appropriate engineering and system selection, the concerns that people typically have over the use of ammonia or high pressure CO2 and other natural refrigerants, these barriers can be overcome. So if we look at some of the sort of large scale projects that we've been working on recently, early last year we completed a large scale distribution centre for Woolworths in Queensland. That's in the order of 7,500 kilowatts of capacity between freezer and chilled, all on ammonia for the low temperature stages, and then glycol for the medium temperature and staging areas. And one newer thing for us, I guess, was the use of modern reciprocating compressors, which come with inbuilt maintenance monitoring. So the beauty of these reciprocating compressors is that we can run them on variable speed and we can really match the load nicely during part load conditions. As many of you will realise, that these facilities don't run at full load all year round or even all day long. Another couple of facilities we're working on with the Hilton Foods in both Australia and New Zealand. These are meat packaging and processing facilities in the order of 3,500 to 4,000 kilowatts capacity. CO2 cascade for the low temperature stages. And again, a combination of ammonia and glycol for the medium temperature. Interesting thing about these, Hilton Foods, I guess from their European experience, are early adopters of ammonia heat pumps. So we were recovering waste heat from the condensers and oil coolers and using that with an ammonia heat pump package to provide process hot water. One we've got on the drawing board at the moment is a new facility for Lineage, New South Wales. That's ASR, big automated freezer, standard freezer, and then staging areas. That's all to be on ammonia. And this will be ammonia DX. No doubt you'll hear more about that later today from my friend Stefan. And because it's ammonia DX with the low charge and the use of air defrost, the concerns about potential ammonia leakage and occupant safety can be addressed satisfactorily. Another one that we did a couple of years ago was a large new winery in Mildura. That was back when there was still Chinese investment in Australia, but we won't say too much about that. It's a large ammonia and ethanol brine system. Many of you would say that's fairly traditional for wineries, and indeed it is, I guess, but we spent a lot of time with this one making sure that things like pumping power was minimised, condenser fan power minimised by using EC fans on the condensers, and all of those kind of technologies to try and drive the life cycle cost down. In mid-sized projects, these aren't always the domain of natural refrigerants, but increasingly now we're seeing that being picked up. Woolworths are currently building an order fulfillment automated warehouse, which is essentially a a facility for providing orders to supermarkets, and the theory being that it's highly automated with minimum people in them. So that's in the order of 140 kilowatts on a low temp system, 400 kilowatts medium temp, 230 kilowatts or thereabouts in the high temp for produce. This one we've done fully CO2 transcritical, and we've used adiabatic assistance on the gas coolers. Another one, the City Kitchens, which is a new packaged meals facility currently being built in New South Wales. Again, CO2 on the low stage and the blast freezers, and an ammonia system with glycol out in the production areas. And we're also using warm glycol, which recovers condenser and desuperheater and oil cooling heat again for the freezer defrost. So that saves using electric power for defrost. Another one that was completed last year is Marley Spoon. It's another packaged meal, kit meal provider. It's a CO2 ammonia glycol cascade. It's heading towards a low charge system. It wasn't ammonia DX, but it did use plate heat exchanger condenser and cooling tower just to keep that ammonia charge down. This was the first time this particular client had used ammonia. Previously, they'd done 404A air-cooled kind of applications, and very happy with the end result. You've heard a little bit about retail projects already from Dario, but some of the ones that cross our desk, LD Australia have committed to CO2 transcritical for the majority of their new sites in 2022 and even 2021. They use a particular integrated subcooling technology which uses CO2 as a refrigerant in the subcooling. Because of the kind of volume and standardized approach that they use, they've been able to drive the price uplift associated with that to less than 10% compared to what they were traditionally doing, which was the CO2 134A cascade systems. And even in spite of the high ambient temperatures that we get in January and February sort of thing, they've been seeing energy savings on the order of 10% over a year. And we'll see a bit of that when we get to some energy graphs in a minute. LD have started using energy performance benchmarks as part of the contractor's specification requirement. This is something a bit new to Australia. People in Europe, I think, might have been using this for a while, but what we're essentially saying is, well, look, we've got a certain energy threshold that we expect you to meet, and your proposed equipment and design has to do that. Another retailer that we work with, again, one of these ones that operates multi-sites, is Ritchie's. They've adopted the use of CO2 transcritical with integrated HVAC heating and cooling off the same transcritical packs. They did a toe in the water a few years ago with that, and we're happy with the results. And so now, wherever possible, that's the way forward. They've also required that their tenderers state the predicted energy consumptions at time of tender, and that's used as part of the evaluation process. This, for us, again, is a bit of a new process, and I guess we're kind of feeling the way with it, but I think it's definitely the right way to go. So some photos. I mentioned earlier the Woolworths DC, which has the reciprocating compressors with the integrated maintenance monitor. And on the left there in the picture, you can see the display. So it's showing that it's had 1,400 hours running, and the next predicted inspection is in 7,500 hours time. So it's looking at things like the compressor speed, cylinder head temperature, pressure and discharge, and all the rest of it. This is a way of trying to overcome, I guess, the traditional concern that reciprocating compressors are expensive to maintain and run. If you can skip a couple of maintenances that normally would be required and still maintain high reliability, then cost picture starts to change. On the right was the 3 medium temp compressors arriving on the back of a truck. I thought that was an impressive sort of photo. You don't often see pictures like that. Oops. So now we were talking before about the Aldi scenario and how we're in a fortunate position of being able to measure the performance of multiple stores and compare how they're actually working. And I think this was something that Dario touched on before too, that use of CO2 transcritical technology does need to be backed up with ongoing monitoring to make sure that it is actually performing the way you'd expect. So we've got an energy benchmark on the left here, kilowatt hours per metre case run per month. And you've got the various transcritical stores, and they're compared against the CO2 R134A cascade, which are the green lines there you can see. So during the colder months, as you would anticipate, the transcritical is looking pretty good. During the warmer months in summer, compared to the cascade, obviously it does suffer a little bit. A couple of things jump out at you there. There's obviously a couple of outliers there, and those are scope for further fine tuning. Even so, when you wrap all this up over a year, as I said, there's still at least a 10% energy saving with the transcritical compared to the cascade standard. This is another winery that we're working on at the moment. They're a smaller size, not that small actually, but relatively speaking. They've traditionally used air-cooled chillers running on R134A, and they needed some convincing as to why they shouldn't be doing that for their expansion. So we used the TEWI calculation, the total equivalent warming index, as a method of comparing the ammonia-based system, which has indirect emissions due to the electricity usage, but no direct emissions because ammonia has a GWP of 0. Whereas on the right here, you can see that the R134A option would have a certain amount of direct emissions due to leakage over its life cycle and a higher power usage. So that all wraps up to a certain number of tonnes of emissions saved over a 10-year period. And this is a good way to represent things to your clients when you're trying to demonstrate why natural refrigerants are the logical choice. Hilton's, we talked about the heat pumps using the waste heat. Hopefully you can see the detail on the screen there, but essentially we're taking a stream of low-grade heat at about 29 degrees entering off the condensers, oil cooling and desuperheaters, running that through a Sabro 108 heat pack and generating output at around 58 degrees through a secondary heat exchanger, which ends up giving us a tank full of 55-degree hot water for process cleaning and wash down. There are still challenges in our part of the world in terms of natural refrigerant adoption, particularly in the smaller clients who still default to the use of synthetic refrigerants and air-cooled condensing units, mostly I think because of first cost concerns. Australia is in a slightly unusual position in that 404A is still available and not that horrendously priced, so the incentive to move away from it is not as great as it might be. We also see that there's a gap in the market for smaller natural refrigerant package chiller solutions, somewhere in the sort of 100 to 300 kilowatt capacity range. At the moment, this defaults just straight to synthetic refrigerants. There's talk of people bringing in R290 air-cooled chillers that will be appropriately certified to meet Australian regulations. And this will be an exciting thing if it is possible and can fit the right price point. Natural refrigerant heat pumps, we are seeing an increased pickup of the air source CO2 heat pumps for smaller applications. But the larger heat pumps, like the one I showed you for the Hilton's food applications, are still seen as high cost options at the moment. I guess that picture changes almost monthly now with Australia experiencing some extremely high gas prices. as Gaku touched on, we don't get any government incentives at the moment that kind of drive these decisions. Again, maybe that's due to change. I've mentioned here a lack of commitment to net zero. A lot of the decision makers we see, I think, are still not thinking long term. They're trying to get over their immediate capital cost hurdles and worry about the future later. We can only hope that that way of thinking is limited and will change shortly. And the last issue that we struggle with is larger HVAC systems still seem to default to synthetic refrigerant solutions. I'm not exactly sure why that is. I suppose it's just because it's the easy way to do it, and there's not that many people promoting, for example, ammonia chill water systems. All right, that was the points that I had to make.
Thank you very much, Jonathan. Great presentation. Let me, first of all, invite the attendees to submit their questions, if there are any. And I have a couple for you. You are in very unique position to be working basically with all the different configuration when it comes to natural refrigerants in both commercial, industrial, and other sectors. Can you give us a little bit of insight in terms of how this decision is made? In terms of, is it CO2 transcritical? Is it CO2 ammonia cascade? Is it DX? I know there's a number of factors, right? But can you simplify this in I mean, your experience, how these projects are usually, being decided, and what is the winning solution?
It's certainly an iterative process. Look, I guess ISECO's starting point would be, wherever possible, to promote a natural solution. That then takes you into a series of discussions about what's the appropriate risk for this application. So, for example, that order fulfillment center that I mentioned, I wouldn't have been comfortable putting them onto ammonia or ammonia DX. They're just not a client that's used to that. They're kind of retailers that have got big sort of thing, but they don't have a ammonia risk management mentality. So that was one of the reasons, for example, that we went CO2 there. Because they are part of a bigger corporate that's already got a appetite for use of natural refrigerants, I think the CO2 was something that they would be willing to take a cost uplift on. Some of our other smaller clients, for example, though, we start off down the CO2 track, and when the tender prices come back, it's, oh my gosh, we can't afford that. And there's a sudden change in design and things go back to a synthetic refrigerant solution. Hopefully those days are coming to an end as the CO2 uplift pricing differential reduces. So I guess those are some of the considerations. It's risk appetite, it's whether the technology is appropriate, and ultimately whether the client is willing to accept the cost uplift. Thank you.
You mentioned with Aldi that the uplift was only about 10% because of their scale and the efficiency.
Even less, yeah.
And yeah, you have been part of the discussions that we had. Was it 6-7 years ago, the first CO2 transcritical systems at Coles and Woolworths? And back then the price premium could be what, easily 50-60%, if not more. We have come a long way.
That's for sure. And again, as Dario touched on in his presentation, the level of experience in the industry has come a long way as well. The number of people now that can do a service call out or a CO2 transcritical install has rapidly increased.
Okay, very good to hear. So I have a question for you. The topic that is quite hot these days, and it's both in Europe and in US. We have heard recently the discussion about HFOs and the problems on horizon and possible control of HFOs or even restrictions on use. The REACH and PFAS discussion and TFAs, the report of acidification of the groundwater and so on. What is the level of discussion in Australia regarding HFOs and these issues? Can you give us your insight into that, please? Maybe just a quick.
I guess, well, from from my side of the fence, very little. It's almost an unknown subject, and we get strange looks when we start talking about contamination of water sources. And so, no, at the moment, I think HFOs are being promoted fairly strongly by certain sectors of the industry, and there's not a lot of pushback on it.
Very interesting. You know, this situation was, again, yesterday, it was the first time that there was a lot of discussion with the Japanese policymakers, the Ministry of Environment and Trade of Industry, and the industry themselves, and some of the attendees yesterday were present in DC and follow very closely what's happening in Europe. And they were making a clear, they were giving a clear statements that this is now a big topic of discussion, and if the ministries are aware of these risks, and the ministries were taking note for the first time. So it felt like Japan is taking note on these important topics when it comes to the risks of HFOs. And, you know, I was also tuned in the ERA show just a couple of weeks ago, and HFO with the TFA was not mentioned once. I think there was a lot about HFO, and it was like, no, we don't think there is a problem for HFO was the answer from one of the panelists. So it seems that this discussion is not yet taking place in Australia. And the question is it the right thing, or should these risks be also discussed? Because we are making decisions for next 10, 20 years, right, when we are installing the HFOs anywhere.
Yes, I mean, at the risk of being facetious about it, I think we're more in a position of one miracle at a time. So we have just had a change of government, and there is a lot more focus now, I think, on global warming and future thinking. Perhaps we need another year or two to get down that track, and these
we will make sure
issues will get traction.
That's good, and there will be much more. There will be progress on these fronts in Europe and US, and then we will definitely bring this discussion, you know, on the stage of Atmosphere next year. So it will be great to see where, you know, how what's the opinion of the industry down under, and we will have the let's say the latest on this research from Europe and America and elsewhere. So thank you, Jonathan, very much for joining. I wonder if there's any question from the audience. Not okay. Stefan Jensen, your good friend, is asking, Jonathan, what is the 100 to 300 kilowatt solutions you are looking for? Which applications? What is the gap that you addressed?
Oh, okay. I'm thinking small food manufacturer, small winery, those kind of people. So typically they would use an air-cooled R134A, 410A glycol chiller, for example.
Okay.
So if we could push them into a hydrocarbon chiller, the safety aspects are pretty easily managed. Usually the stuff's sitting outside, it could be fenced off in an enclosure. Wineries and food industry people are already used to dealing with risks, so it's really just a matter of the equipment being available on the market.
It sounds like Stefan is ready to offer his solution in this gap with ammonia. I'm just guessing. We'll hear more from him in a little bit.
I'm sure it will come down to price point as well, but yeah, if he can meet the price point of an air-cooled chiller, happy days.
I think that this will be off-record discussion when the conference is over, but I'm sure he will address this with you. Okay, thank you very much, Stefan. Stefan and Jonathan, of course, Jonathan, for your presentation.
My pleasure.